Currently, a lot of different drones will utilize a bunch of expensive sensors such as LiDAR as well as infrared, and that requires a lot of battery power and also adds a lot of weight to the drones. And we're achieving autonomous navigation by just utilizing RGB images, so just a single camera right in the front, and it takes a bunch of layered images, and from there it goes directly to controls.
Robotics offers an awesome application for reinforcement learning, which is the approach that we're trying to use in our project. Reinforcement learning allows us to develop agents that learn complex and interesting behavior that are normally really difficult for us to engineer.
Our system is highly parameterizable and builds off a popular open source robotic system called ROS.
We started by making a simulated model of one of our teammates' apartments in which to train our reinforcement learned model.
Yeah, you can hurt the drone, you can break your things, you can injure people. So it's not a good idea to have the drone train in real life.
Reinforcement learning works a lot the same way how you learned how to ride a bike. It's this continuous feedback loop where an agent or you is getting feedback on how well an action performed. DeepRL right now is on the forefront of research for developing complex and interesting behavior in robotic agents.
We actually noticed that the drone started to learn some really interesting behaviors, such as flying under the kitchen counter.
However, it also learned some unwanted behaviors, like flying in circles simply to avoid obstacles. This was a consequence of our reward function, so we added the concept of a start and end goal.
What we did is implement a PID controller. So you can see in this simulation that the drone will start at some starting point A, let's say, and ideally we have the drone turn towards the goal and then move towards that goal. So we have a controller for the Y and also a controller for the angle plus the linear velocity.
Eventually we want to transfer what we've learned to the real world.
Without randomizing, our model is just memorizing our simulated world with pretty unrealistic textures, and we get a simulation bias.
We use something called domain randomization.
Essentially, because we've trained on such a large set of textures and a large set of different lighting spots as well as the intensity of that light, the idea is we'll get some generalization.
Maybe the next simulated world looks like the real world. Since domain randomization is pretty new, there's no open source framework for other people to use. We are open sourcing our tools so that other ROS developers can use domain randomization in their projects. Our final policy gets about a 50% success rate, which is a promising initial result, so that we can avoid obstacles in the real world using only simulated data.